Hello and welcome to another Solana tutorial. Today we're gonna talk about Shank, which is a tool that lets you create IDLs for non-anchor Solana programs. And why would you want to do that? Well, from the IDL, you can then generate the code that you use in your client scripts, for instance with a kit, which makes calling the program easier. And having an IDL that represents the program is just convenient. Also, you can upload it on chain and then everybody knows how to call your program. And with Anchor, that happens automatically. But for native programs, so if you're using pure Rust, then you would either need to write the IDL manually, which nobody does because that's annoying, or you use a tool like Shank that will then auto-generate the IDL based on some tags that you add in your program. And we did see Shank in action in the previous video where we had a look at the agent skills, and the agent skills specifically mention Shank if you have a non-anchor program, that Shank should be used to create the IDL. And now, in times of vibe coding, I judge that it's not super important to understand all the technical details about Shank, how all of the macros work exactly, because your agent will figure that out. But what you need to know is that Shank exists and what it can be used for, such that you can instruct your agent to use it. But today we're not gonna use any agents, we're gonna go with the plain old programming ourselves without vibe coding. And we're gonna see how difficult it is to add Shank to an existing Solana program and then create the IDL from it. And for today I decided we're just gonna take one of the program examples, maybe one of the basic ones. Let's go to the GitHub here. Program examples, basics. I had a look through most of those and they're really basic. But one example that is a little bit bigger and has an account layout and several instructions is this favorites program example. And you see we have an Anchor, a native, and a Pinocchio implementation available. Anchor would look something like this. We have an account layout with this favorites that has a number, a color, and hobbies, and then an instruction for set favorites, which takes the signer, the favorites account, and the system program to create it. And all the instruction does is just write that data onto the account. And if we use that Anchor program, then that automatically will create an IDL. But if we had the same program in native, it would look something like this. It's in several files. The state would look like this, and the instructions come from this enum. One to create a PDA, one to get the PDA, and the instruction is deserialized and matched here. And then the actual implementation for creating the PDA, getting the accounts, doing some checks, checking that it's the correct PDA, and if it doesn't exist yet, we create the account with the system program create account instruction, and then we write the data. So a bit more code because we don't have all the Anchor macros that would do that initialize for us, for instance. But yeah, that's how you would write it with a Solana SDK, so Solana program. And if you wanted to be more efficient, you could do it with Pinocchio, where it would look something like this, where you don't deserialize the entire instruction, but you just match the discriminator first, but the implementation would look relatively similar. And then here you just copy directly from the instruction data because it's the same format. So yeah, this is more efficient, but doesn't matter. Today I mainly want to have a look at this native implementation. So let's clone this repository. Git clone this. Cool. Actually, let's first look at the Anchor program, just so we know what we're comparing to. Because if I would here say Anchor build, there we go. Now we're building this program. This one actually just has one instruction. In the Anchor example, it just has one instruction. Cool. And if we build that, then in target IDL, we should have this JSON file that is the IDL representing our program with some metadata. It's called the favorites program. That's the version. And then it contains a list of instructions where the one instruction is set favorites, which has this discriminator, and those are the accounts. Namely, we have a writable signer, we have a PDA, a writable PDA with the following seed or seeds, and then the system program, hard-coded with this address. And it also says what are the input parameters. And then we have a list of accounts, namely our favorites account, that's the account discriminator, and that's what it stores. Again, a number, color, and hobbies. Cool. And that stuff is auto-generated by Anchor, and from it we can use Kodama to create the client scripts. But this is not what today's video is about. Today's video is about Shank and how we can create such an IDL from a non-Anchor program. So let's get started and open the basic favorites in native. Let's go. So in here, we have this program that is split into several files, but it should actually be working the exact same way. It even has a separate instruction for get PDAs or get PDA, and what that does is it writes a message. Maybe the Anchor program doesn't specifically have that instruction as well, because if you have the IDL and you know the accounts, then you can just parse that from a get account info, but you know, whatever. So it's not the exact same. But anyway, this should already build. If I just say cargo build SBF, then this program would hopefully... Oh, why do I get an error? Oh, counter Solana Pinocchio. Why are we compiling this stuff? Oh, because we're compiling all of the projects. I don't want to compile the Pinocchio stuff. Can I tell you to just use programs, the program source program cargo? Then you should just build this one. There we go. Why are you messing with my tool chains? Do I want to know? Probably not. But it seems like it built that. So somewhere out there must be a target. There we go. And in here we have our favorite native program. That's just because we imported all of the examples. It thinks it's one big project with several programs. So my target deploy is further out. But it doesn't matter. It managed to build, so it's fine. But obviously it didn't create an IDL. It just created the SO file. And I would like to have an IDL for this. So we're gonna use Shank. Metaplex Foundation Shank. Here are docs. Shank, developed by Metaplex. We have a CLI that we can install. Let's do that. I think I did it in a previous video already, but let's see. Yep, I did install Shank already. It's already installed. That's the tool we're gonna use to then create the IDL, but the program also needs to be annotated, and for that we need to add the dependency to our program and then add those annotations. And then we can run Shank IDL. If you try to do that already, let me clear and make dir for IDL, and then I would run this. Okay, it needs the path to the program. There you go. There we go. It found the cargo toml in here, but could not find a declare ID, program ID. So it tries to know what the program ID is. We can tell it manually, use this one. I don't know. I'm gonna create one. This is, by the way, bad practice. Don't put keys. I just do that for testing. Should I not do bad practice stuff and store my local key pairs literally right next to the program? Maybe, but it's just for demonstrating. I just want to say, hey, here, have that favorites program. Bavu, that's going to be the program ID. So I'm going to copy that to target, deploy, favorites, key pair. And then when I run this, I could say, hey, use this program ID because I didn't annotate it in my program. And then it could already write that IDL, but as you would expect, this IDL will be fairly empty. Oh wow, it's not even that empty. We have a favorites native program. We don't have instructions, but it did find types. It did find my favorites struct with those fields. Okay, so it takes it all as types. My favorites and my get favorites, it found those types. And then it also puts the program address because I provided that, and also says this was created with Shank. So actually there's more in there than I thought, because it did find the stuff that you have here in the state. There's a favorite struct and the get favorites, and those two it put in here. And even the instruction, so this stuff, it found another enum. All the enums it will just take as types. Cool. So you don't explicitly need to annotate them as such. It will just find them. Okay, fair enough. But this is not really usable yet, right? With types we can't do much. We want accounts and instructions. So we gotta annotate our program. Maybe I go to the macros reference for that. Shank type. I think that's what it did so far, and it implicitly added that to any type that I have in my program. Okay, but what was the thing with the program? Docs on that are not great, must admit. So let's just do that again without that -p. Oh, it's just a regular declare ID. I'm just gonna add that, and I would just in the lib Solana program declare ID and tell you your program ID. That way, if I now run it without the -p, it should also write the IDL and take the program ID from here. Okay, so that was the step one. We also have the program ID now inside our program code. And now let's start with those annotations, and for that to work, we need to add Shank. So cargo add Shank. What the is that? Oh, it doesn't know where to add it. Fine, let's go here. Now we're in the program, and inside the program it has the, yeah, maybe I should stay in here. Then also the cargo build SBF should just build that program. Yeah, There we go. Cool. We added Shank, did we? Yeah, in version 0.4.8. And now that we have that, we should be able to add those annotations. So we want to add them for instructions and accounts. Let's start with the account. Why not? So we have a derive Shank account in our state. This is how our account will look like. I'm gonna add this derive Shank account. Could also put it in the list up here. And then I will need to import that from Shank account. And hopefully that will just work. Get favorites, that's an instruction. I mean, see, that thing is double used. It's once used as an account and once used as instruction data or parts of instruction data in the processor here. This instruction data also takes the same format that we then also write onto that account, where we serialize that data, and that data has type favorites, so that one-to-one goes onto the account. It's also how the account looks like. We don't even have a discriminator in this case for that account, but we only have one type of account, so whatever. Great. So Shank account, let's see if I just add that. First of all, if it still builds. Yes, it does. And then if I run this Shank IDL again, it produces me a new IDL. There we go. Ha! So now this is in accounts. Accounts has a favorites account with the following fields: number, color, string, hobbies, and it says that's a U64, that's a string, and that's a vector of strings. Is that the same as my anchor did? In my anchor, I had accounts, favorites, and then, no, anchor then also did types. Wait, that's separate. Interesting. Anchor has a favorites account. Wait, let me see the source again. Yeah, that's the account. I would have expected that it puts that as part of the account, but okay, whatever. I actually prefer how my Shank does it, because inside the accounts we have fields with those three. Again, we don't have a discriminator. We didn't define a discriminator in that program. Okay, and the other two things, they're still in types. I actually don't like that Shank just puts everything in types. Maybe I could configure that. Shank IDL. Nope, there are not many options for that. Okay, fine. I'll just have to live with that being in types. Fine. Good, but the good news is we do have this account now. Let's proceed to instructions. And my instructions, they are parsed from here, from this enum. So all I gotta do is derive Shank instruction from the same enum with the Borscht deserialize and serialize. We add Shank instruction and save this. We obviously also gotta import that from Shank. And then if I run my Shank CLI again to create the IDL, now I should have something in instructions. Look, I have a create PDA instruction, which takes favorites, which is a defined type. Nice. Do we actually have that type in types? No, because here's just the get favorites now that was left in types. So that could be an issue. But it does understand that we have a discriminator of 1 byte and it's 0, because standard enum, if we look at the actual processor, we match this instruction and the instruction that's an enum. So 0 is the create PDA and 1 is the get PDA. That's also reflected in our IDL, because the second instruction is the get PDA instruction. It doesn't take accounts, doesn't have arguments, and it has discriminator 1. So nice, it put that in there. And with this enum now being a Shank instruction, it doesn't put it as a type anymore. I don't know why are we ever using that actually? What is that being used for? It's not used, is it? I don't know why that's here. Actually, what happens if I just delete that? Will I get a problem? Will something not compile? No, it compiles just fine. We didn't really use that anywhere because this doesn't take any arguments. That's just that. So I like it better like that, with that deleted, because then if I regenerate my IDL, I don't have types anymore. I just have accounts and instructions. Great. But in a way also not great, because the favorites expects a type from a defined type favorites, and I think that could be an issue because we are reusing this favorites both as an account but also as instruction data type. So maybe I should put Shank type here as well and then rebuild our IDL. Nope, but it still doesn't put it as type. Maybe if it's in accounts favorites, that's fine. Maybe that's already enough. Okay, since it doesn't change anything, maybe I don't need that type. Fine, remove it again. And I would say with that, we're already done for this small example, because we have our instructions and we have our accounts in the IDL. That wasn't so difficult. But let's see if we can actually work with this. We created our IDL. Let's use it. Oh, hold on. No. We're not done. You see this? This is still wrong. We have our instructions and the arguments are correct, but the accounts are missing. We did not define what the accounts are. Because in Anchor, that's done with the derive accounts, where we say here what the expected accounts are. But in a native program, let's go to an instruction. This is only like implicitly here when we get the accounts from the next account info, where we say, oh, we need a user account, we need the favorites account, that PDA, and we need the system program account, or at least that's what we're expecting. So that I also need to write into the IDL. And obviously Shank doesn't just know that, we will need to explicitly tell it that. How do we do that? By inside the instruction add those account tags here, something like this. So where did we define our instructions? Here with the Shank instruction, and then we say account. There, Shank macro, derive helper, account, and what does it take? The account, here it is. It takes the index, it takes writable signer or optional signer, whether or not that's an optional account, and then the name and an optional description. So if we have a writable signer, then we both say writable and signer, because all of that is optional. Okay, and we'll need that later as well. The known accounts. If the name matches one of the known accounts from Solita, then those will be used. That's token program, ATA program, system program, and rent sysvar. Solana IDL to API generator. Solita. Okay. Oh, so that's maybe then to create our IDL and not Kodama. Kodama probably does a similar, if not the same thing. We'll have a look, but that doesn't look very kid friendly though. Anyway, known pub keys. That's what I wanted to have a look at. Token program, ATA program, system program, rent, and program ID, which it takes from the program ID export name. Okay, so those would be the things that I can specify. Cool, good to know. Back to here and this. So when we define our account, we put an index, whether it's writable, whether it's a signer, and the name. So our first, let's look at this side by side. For the create first account is the user account, which is a writable signer. Perfect. Then the second account is the favorite account, which is writable, not a signer, or yes, wait, that must also be a signer because we created with a system program then, right? Yeah, so I guess we also expect that to be a signer. Favorite account, PDA for storing data. And then the third one is the system program. This one, number 3. This one, I need more space. I'll go away again. This one, number 3. Interesting. If I have 3 but no 2, then it complains. Ah, good. This one is definitely neither writable nor a signer, but it's also not optional. And this name system program, and we know that that's one of the known names, so it will just take that. Now for our favorites account, I would love to also provide the seeds, but I didn't see that that's a possibility. I don't think I can put seeds here, which is annoying. Is there something with seeds? Seeds. You can include a seeds annotation, which allows Shank to generate the following. Okay, we can have a literal, we can have the program ID, we can have a explicit pub key, we can have a pub key given by a pub key, we can have a byte, and we can have a string. Wait, but how do I do that? I would need to do that in Shank account. Oh, I would do that in the Shank account. When we derive the Shank account, we can provide seeds. I see. But then how do I link this account, for instance, this favorites account, to the appropriate account? How does it know that it's of that type? If the name matches, provides the name for the account. Okay, let's just play around with it until it works. So we know for a Shank account, we can add seeds. So let's try that. Same way we add accounts for a Shank instruction. For an account, we can use seeds, and there we can have a literal, a pub key, and so on. What are my seeds again? We find for this literal and then the user key. Okay, so first for this literal, not sure if I need to write lit or if that entire thing is the literal. We'll see. And then I want a pub key. This is still very confusing. Like, how can I reference the user key then? Here you have no reference to the user. Here this is just the state data. The users actually come from here. I want to use that. Okay, it's getting more complicated than I thought. User and pub key, non-item in item list. Okay, I don't know about this yet. Let's try without the seeds for now. If it at least adds those accounts to my IDL. So the create PDA now has an account user. Nice. It has an account favorite. I definitely spelled that wrong. And maybe I should just spell it the same as you did for the actual favorite account. There we go. So my docs say it's a PDA, but we don't have the seeds in here. Like in Anchor, the IDL would look like this, and the instruction set favorites has the account user and favorites where it says it's a PDA with the following seeds. Something like that I would also love to do with Shank, but maybe that's not possible. Maybe it will just be able to do that on the account level, but it's a different thing. It's weird. Why would you put it on the account level? It does not make sense. But anyway, the system program, it also just has the name system program, but doesn't look like it's actually... I think this then only works if we are using Solita to create the TypeScript code. If we're using Kodama or anything else, then it might not have the same known addresses. So those known addresses for Solita, this is a known address. Anchor would actually provide the address, which is convenient. But okay, let's just accept that that's how it is. And the arguments favorites is defined in favorites. So it's a not so nice IDL yet. I really am not happy with it. But let's quickly do the same thing for the get PDA. Just so this guy also has accounts. It takes the user and the favorite. The user just to derive the favorite. Okay. So basically I copy this, I paste this. I don't need the system program, and the favorite account doesn't need to be assigned anymore. Oh, it also doesn't need to be writable in this case, because we're just reading. Okay, and like that, we update our IDL. And now also the get PDA has accounts, but it doesn't provide the seeds. Let's see, do we find something in docs for that? Seed, nope. Macros reference, seed, nope. This is pretty bad documentation, eh? It's just not supported, but also there, I don't find seeds. What language do you think I speak? But still, there's nothing about seeds. What did we read here then? Seeds is specified for an account. It will derive the following static methods for that account. Oh, and there it then takes those arguments. Maybe let's start with just the literal. Oh, it also already doesn't like this. Non-item in item list. Doesn't seem to like that at all. I feel stuck. This doesn't seem to work. Maybe Shank doesn't support that. Or I ask AI. The account field names account must match the account names declared in your instruction. Okay, I said no vibe coding, but I'm lost without vibe coding, so vibe coding it is. Seeds, that's how it seems to work. Let's try that again. So it says that I can use literals like this. Let's try. Yeah, and the literal was favorite and then the account user. But no, it also doesn't like that actually. Aha, getting somewhere. Account needs a description. Do you see that somewhere? We don't see that here anyway, but something needs descriptions. Pub keys need descriptions. The literal doesn't. Okay, so literal doesn't need a description, but account does. No, it doesn't. Second argument to parameter needs to be an unquoted Rust type. Literal program ID pub key with description key instead of account. Nope. Quite different from the docs I referenced. Yeah, because they're not up to date. Here's the fix. Favorite and then pub key the user this account belongs to. But then how would you reference? How does it know that it should use the user here? And also, no, this doesn't fix shit. Yeah, I think I give up. I don't see how that should ever work. Or, let's try something. Reopen this in a container. I've told myself only to use Claude in a container anymore. Correct syntax is name, description, type. Okay. We also need pub key and scope. Okay. But even with that, also that doesn't fix shit. Okay, admittedly this is getting a bit annoying. Even with vibe coding I cannot fix this. And the docs don't say anything about seeds. So maybe it's just not a thing. Maybe I just shouldn't use that. Seems like Shank is limited in the things that it can do compared to a full-on Anchor IDL. But it has enough to do accounts and instructions, at least a little. So I think I'm gonna move over to creating actual code now that we have an IDL with the instructions that do have accounts and the accounts definition themselves. Should be enough to generate some TypeScript code such that we can easily call those instructions. That's the goal now. Let's see if that format that Shank spit out actually works with Kodama. Let's run this. Cool. It ran. Did it produce my generated code? It did what's in here. Oh, we have a create PDA, a get PDA, and a get PDA instruction. Look, that seems to work. And it has the discriminator 0. It took that from the IDL. I can create a PDA instruction. It does understand that it should use the system program, so nice, that worked. And it does understand which accounts to use. Accounts user, favorite account, system program. But it doesn't have the PDA info for that, so we will need to provide the correct account for this. We couldn't have the seeds in here. But that's already quite good, honestly. I think I'm actually already quite happy with this. And accounts, we have the favorites account, where we have the encoder that will properly and decode that account for us. Let's use a quick kit script. Wait, but here we do have a problem. It takes stuff from types, but we don't have any types because our IDL is talking about type favorites here, but we don't have a favorites type. That's why we didn't generate any type here. And that's why here this thing is failing. It's bad. That's very bad. Because if I then try to import this, I try to get create PDA instruction, for instance, get create PDA instruction, which would take, interesting, the user, the favorites, and the favorite account. Why does it take 4 things now? User makes sense, my payer. System program is even optional, so that's great. It knows what the system program is. But then I have a favorites and a favorite account. Why is that? Favorite account is a transaction signer. That's the PDA for storing. Okay, and then favorites. Oh, the favorites are the arguments. Yeah, that makes sense. Okay, no, it does make sense. So the one thing is the favorite account that we still need to derive. Got program derived address. Since it didn't manage, we do have the favorites native program address though. It managed to have that in the IDL and therefore in the generated code. I can access that. Perfect. But the seeds I will manually need to put in because it couldn't encode that in the IDL. So favorite, but spelled the American way. And then the user, so in my case, the payer address with a get address codec encoded this thing to get the bytes. Okay, so that's my seeds. Then I have the favorite account and then that should hopefully work. No? Oh, this needs to be a... What? Hold on, I thought there was a PDA. Wait, what was a PDA then? Something doesn't make sense here anyway, because either it's a PDA and then I don't need it as a writable account. Obviously, it's a PDA. My bad. I actually made a mistake when I was doing... Where is my program? Here, when I was writing these things. The favorite account obviously doesn't need to be a signer because it's a PDA, so it can't be a signer. Okay, if we remove that... And we also remove the seeds again because that doesn't work anyway. Just check that's still building. Okay, builds. And then let's do Shank again. How did it go? Generate that again. So now signer is false. Then we run Kodama again. And then in here we should hopefully have this just as an address and not as a transaction sending signer. Perfect. And now we're just missing the favorites here, which it says it's favorite args, but that it can't import. So it doesn't have the types for that. So something is still wrong. And if I would try to run this, audio not found, generated types. Why? Imported from here, types. It just doesn't find that. It doesn't have the favorite args. So somehow we still need to get that type into our IDL such that it knows that. How would we do that? I don't know. We somehow need to also get it into types. That's a recursive description. The only idea that I have, basically this is what I want. And it's a bit stupid, but what if I once have it as an account and once as a type? Then I have conflicting thingies here. What if I call that arc? What could possibly go wrong? Let's see what happens if I create the IDL from this. Let's check the IDL. Do we have types now? We have the accounts and we have types. We have favorites arc, but I don't know if that's the name that we should call it, because up here it references the type defined favorites and then accounts name is also favorites. So that's still weird, but oh well. I'm just gonna generate and then see. Yeah, now we have types, but we just have favorite arc type, favorites arc decoder, and this thing is expecting get favorites decoder. So obviously that's not what we want. That's all a bit stupid. Okay, so I'm gonna call this one the favorites one and then this favorites account, and really it doesn't matter which one I use anyway, because here we get it in as favorites as the type, and then when we write it we just write that onto the account anyway, so this is never used, like this import, but I'll have it in my code anyway, because then that's an account, because I want that account to be generated as well. Anyway, it's stupid, but here, create that IDL, and Kodama generate the code from that IDL, and then let's see, now that works. I think now we have the favorites account. It's just called different now. And the instruction. Ah, look, now we don't have types. Ah, it didn't create us types anymore, but it took it directly in here into this PDA instruction data encoder. So the instruction data from the create PDA instruction now directly contains the right values. That's much nicer. Cool. Because then in my sending script, I don't use this favorites with it, all of it, but I have the individual things that I put as instruction data, namely color, hobby, and number. My favorite number obviously being 101, my favorite color obviously being purple, and my hobbies being, how do I put that as a vector, as a string array, vibe coding and generating IDLs, favorite hobbies. And that should now actually run. Let's see if it does. It does not. Oh, because we didn't deploy the program. Yeah, I mean, okay, fair enough. That's a valid reason not to work. So yeah, where does our program live again? Solana program deploy somewhere outside in a target. Nope, further outside. Target, deploy, favorites native SO. Let's go. Deploy that. There we go. Our favorites program is deployed. And now if I try to run this, ha! I can send that transaction. Nice. And this is the code I used to create this transaction. And look, I can call this program. This favorites account is being created with that data. And that's the same data that we then also, except with a 0, that's the same data that we then also find on that account that we created. And we even log the favorites here because we're not being CU efficient, but who needs that? And so if we check the account, we actually have that same data on that account as well. Look, we even see our favorite color and our hobbies on here. Nice. So that worked. That worked. It's just a bit inconvenient that we don't manage to get the seeds for the PDAs in here. We can't derive those accounts. We still need to manually know what seeds are being used for that. Sadly, with the Anchor IDL, that's a bit easier to compare. If we did it with the Anchor IDL, where does that one live? Favorites JSON. This one instead. Let's put it for Anchor. If we created the stuff for Anchor, then we would get PDAs, and the favorite PDAs would then contain the seeds, which is a literal, and the user seed. So we could do stuff like in our send transaction script, if we import that from the Anchor Kodama source generated, then here we would have the favorites decoder. It's called find. The find favorite PDA. So we wouldn't need to know that ourselves anymore. We could do our favorite account is find favorites PDA. Await. And the seeds, it just needs to know the user, which in our case is the payer address. So we don't need to know that string literal anymore. And then we would also get the same account, and that should also work. Because the Anchor program is indeed using the same seed as, or is it not? Does not provide an export name for. You're getting a wait, that's what I'm missing. I need to get the actual address, not the PD, not the bump. There we go. Then, oh, we have an incorrect program ID for instruction. True, fair point, because we were now deriving that for a different program ID, of course. I don't know why it gives me that error. Checking if the favorite account is the same as the derived one, so the derivation didn't work. We get incorrect program ID, which I don't know if it's the right error, but it's certainly the error being used here when we don't have the right PDA. And why do we have the wrong PDA? Well, because our Anchor program uses a different program address to derive this. But my point was just, if we had the PDA seeds in our IDL, then we had this nice function that Kodama would create for us so we can easily derive it. Otherwise, we need to know the seeds ourselves. But good enough. I would say good enough. I could not figure out how to work with seeds with Shank, but we did manage to put in the account and the types and also the instructions with the accounts, such that we can use Kodama to generate that code so that we can have these nice little helpers in our TypeScript, which makes calling the program much easier. Good enough. So admittedly, I'm not the biggest fan of Shank It's a bit annoying to work with, honestly. It doesn't support all the things that I would love to have in an IDL, like seeds. And even with a bunch of vibe coding, I couldn't get that to work. So it just doesn't seem possible, or I don't know how. I mean, there are no docs on that, so yeah, that's sad. But if you just use it for like simple things, like a few instructions and a few accounts, you can use Shank to automatically generate your IDLs, which is more convenient than writing an IDL yourself. I would never recommend writing an IDL yourself, because that will quickly get out of sync with your actual program. As soon as you change something, you will forget to change it in the IDL. So if you want an IDL, then auto-generating it is the way to go. And if you're not using Anchor, then Shank is an acceptable possibility. I don't know of any other tools that do the same thing. So I will use Shank, or tell my agent to use Shank. And also, we just looked at it for a native Solana program. With Pinocchio, it also gets more complicated because it doesn't do the Borscht schema. It is possible, but a bit more complicated. And honestly, I'm a bit afraid of doing that myself manually, because there's just no good docs on it. And if it doesn't work, I don't know why it doesn't work, and that's just frustrating. So anyway, if I want to use Shank, I will just tell an agent to add those tags for me. Yeah. But it's good to understand how it works in general. Just have a basic understanding of the steps you need to take, add those annotations, and then run the CLI to produce the IDL, which we can then use to generate code with Kodama. Having a bit of understanding of this is good. You don't need to write all of the code yourself. As I said, days like these, we have AI, but also I still want to keep my understanding. If I'm telling my agent to use Shank, I want to at least know what it is. And now we do. We tried it. It's good. It's not great, but it's a tool that we can use. Got it on our belt now. Cool. With that, I will finish this video. Here's some other ones that you can watch. Subscribe if you have not done that already, and I will see you in the next one. Till then, bye-bye. Not even gonna tell you to like this video because I don't like it myself. Even though, really, it wasn't so bad. Was it so bad? We know how Shank works now, right? And we've seen it in action. And we saw a few of the caveats. Things that it's not so good at. Which is also good to discuss. Hey, maybe MetaPlex, if you're watching this, might want to add or document those features about seeds. That would be helpful for me and my agents. And with that, I will see you in the next video. Bye-bye.